Settle kan? Quantitative last week kan? Ada lagi?
Ada sikit lagi on normality test. Ada normality test sebab last week tu dalam around 10 slides to go lah.
Kita stop dekat other normality test table 38.2.
Oh, tak sabar nak masuk ni. Tak sabar nak masuk kuali ni. Mana?
Slide 41.
Satu. Okey, hold on. Okay, kita refresh sikit. Okay, kat sini Okay, so last week we learned about the two types of data. Kalau kita divide according to the the requirement of normality. Okay, so as much as possible, okay, kalau when we conduct a study, we want to make sure that our data are normal for the quantitative study. Okay, quantitative study bila kita buat kajian, kita kalau boleh seboleh-bolehnya kita nak data kita normal. Why? Because we have more options. Okay, we have more option. Most of quantitative research, quantitative analysis ni, most of quantitative data ni, if you have a normal data, okay, you have options either to use analysis that require normality, or the types of statistical analysis that does not require data to be normal. Kita ada dua-dua pilihan. Maksudnya kalau data normal kita boleh guna sama ada parametric or non-parametric statistic. But if our data are not normal, we only have one option, okay, which is we have to proceed with non-parametric analysis. Okay. How many of you are not yet attended statistics class? Majority ke minority? Majority. Minority. Majority. Again, majority.
Yes, majority.
Okay, majority. Okay. Okay, tak apa. Kalau majority, I thought I need to share another slide lah, so that you have a clear view regarding data normality.
Doktor,
yes.
nak tanya.
Yes.
Apa yang menyebabkan data tu jadi tak normal?
Okay, what are the factors influencing data normality? So one of the reason is outliers. Outlier is something that is beyond the standard, because in quantitative we are interested in the standard or the normal value. Kalau kita contoh for example based on the skewness ni. Okay, we are interested in the majority score. Okay, the norm within the group. We are not looking for the uniqueness. Okay, different with qualitative, we are looking for the uniqueness of the individual uniqueness. But in quantitative study, we are looking for the similarities. We are not looking for the something beyond. For example, contohnya majority pendapatan di Malaysia 5,000 hingga 7,000 majoritinya. Okay, but there are some that might have the salary around 12,000. So we are not interested on that 12,000. We are interested to study this majority, the similarity ni. Okay, so apa yang menyebabkan data not normal? Outliers. Outlier ni kadang-kadang ada dalam satu kumpulan tu. In one group ni ada someone that is unique, different from others. Faham tak? Faham? Tak faham?
Faham, Doktor. Cuma kalau if we do the quantitative research, then we get the not normal data ni, kita kena usahakan dapat yang normal ke?
Okay, kita kena usahakan, but there are a few ways that we can make sure that we can transform our data to make sure it is normal. Ataupun there are few alternative that we can try, okay, so that our data becomes normal. We are not manipulating the data, but we are just transforming the data according to the statistical formula. Dia tak sama macam kita manipulate data. We are not manipulating the data, but we are just transform the data according to the statistical formula. Faham Faham, tapi
thank you.
But if let's say after we do the transformation, the data are still not normal, so we have no choice. We need to proceed with with the non-parametric statistic. Okay. Sana. Saya nak cari slide data.
Hai guys, Assalamualaikum warahmatullahi wabarakatuh.
Siapa punya talk pula tu? Perdana. Kat mana saya letak ni? Tak apalah, tak jumpa. Tak apa, nanti saya akan share lah. Okay, kalau ada soalan along the way, please let me know. Okay, so kalau boleh, the normal distribution ni equals to the symmetrical. Okay, symmetrical ni if we can imagine the bell shape. Okay, the most easiest is bell shape. Bell shape, kalau data kita dalam bentuk bell shape, if our data is in bell shape form, so we can assume that our data are normal. So another formula to determine either our data are normal or not is based on the value of mean, median, and mode. Okay, if the value of mean, median, and mode for our data are quite similar. Okay, so we can assume or we can conclude that our data are normal. Okay, so we can make comparison. So to run the normality ni, mostly your data must be at the at the ratio or interval scale of measurement only. Okay, untuk kita buat normality ni, data normality ni untuk interval or ratio, okay, we can for the data that are for the data that are in nominal or ordinal or in categorical form, we cannot run the normal distribution test. Okay, so normal distribution ni only applicable for data in either in either interval or ratio only. Okay, hanya untuk data that are continuous in nature. Dia tak boleh untuk data kategori. Dia hanya untuk data continuous. Contoh, for example, salary, okay, speed, test score. Itu contoh for continuous data. Okay. Ni contoh. Okay, so what other than looking at the value of mean, median, and mode, okay, we can check the data normality based on skewness value. Okay, skewness value. Okay, so skewness ni referring to the extent to which a distribution of score deviates from perfect symmetry. So the rule of thumb dia ada 3. Either you use the most stringent one plus minus 1. Okay, plus minus 2 considered relatively normal or plus minus 3. Okay, kalau if you want your data to be to be macam cantik, so you please use plus minus 2. Plus minus 2 ni biasanya kalau you run the correlation and so on, biasanya the finding pun would be good, would be very good. Okay, so where can you get the skewness value? Okay, if you run the Ibm Spss, okay. By the way, are you familiar with Ibm Spss? Just wonder. Familiar tak?
Not so.
Not so.
Not so.
Not yet, Doctor.
Not yet. Okay. Let me introduce to the Ibm Spss software then. Sambil-sambil. Sebab nanti tak tahu mana nak dapat skewness value tu dah. Okay, hold on Okay, later on when you attend statistics class, so saya rasa it would be better if you already have the install as IBM SPSS in your system, in your device. You can get the pirate version. Boleh dapatkan pirate version. Ada setengah orang tu dia beli daripada Shopee je. Sekarang ni macam-macam kat Shopee, semua benda ada. Okay, so this is the software. Okay, this is the IBM SPSS software. Okay, so IBM software ni there are 3 main windows. The first window is for data editor window. So this is the data editor window. Okay, and then the second window is the output window. The third one is syntax command, syntax editor window. Dia ada 3 tertingkap 3 windows. So this one is data editor window. So data editor window ni dia ada 2 column. Data view and variable view. Okay, data view and variable view. Okay, untuk enter data ni saya tak ajarlah untuk kelas ni Okay, untuk ni kelas research method. So I just show you on how you can get the skewness value. Okay, to run the skewness value, you click analyze. But first make sure that your data are in either interval or ratio. So for example, in my case, okay, harga, ni sebenarnya data. Okay, so harga saya guna nilai lapo ni. Okay, nilai lapo saya guna nilai LPR ni nilai lapo. The reported value. Okay, the reported value or the property reported value. Okay, so to get the mean for the reported value ni. Okay, so I click analyze, I click descriptive, I click descriptive. Okay, so I choose the value for the reported value, nilai lapo. Mana ni nilai lapo ni? Okay, nilai this one. Okay, and allocate under the variable box. Under option, I tick for mean. This one tak nak. Standard deviation, kurtosis and skewness. Okay, so I tick for these 2 options. Okay, so I click continue and then okay. Okay, so I go to the output window. So this is the output window. Ini tertingkap output. Jadi the data editor. So this one is the output editor. So based on the output editor ni, so I look for the kurtosis value. Skewness value. So this is the value for skewness. Okay, ini value dia skewness dia 17.144 for example. Okay, 17.144. Okay, so if we compare to the cut-off point given previously, which is plus minus 1, plus minus 2, or plus minus 3. Okay, so the value ni beyond the plus minus 3. So based on skewness, we can say that okay, the data are not normal. Faham? Faham tak? Is it clear? You just forget about how you can get the value, but how you can read. Focus on how you can read the value. Okay, based on the skewness value, since the skewness value for the reported value, nilai lapo is 17.144, which is beyond the plus minus 3. So we can conclude that based on skewness, the data are not normal. Faham? Faham tak?
Faham betul.
Faham doktor.
Kita dah start pening lah. Saya masuk sikit je. So that you all faham lah mana nak dapat, mana macam mana nak baca, itu paling penting. Okay, so next one we go again to our slide.
Doktor.
Yes.
Tadi doktor cakap for the data yang bagus, it is better for us to have plus minus 2 kan?
Yes, plus minus 2 yang cantik plus minus 2, but kalau kita tak nak stringent sangat, konservatif sangat, then you can proceed with plus minus 3. But after all, 17.144 still exceed either either 2 or 3, right?
Yeah,
so
yeah.
Far beyond the cut-off point. So it is considered not normal lah. Okay, so faham macam mana nak dapatkan nilai dan macam mana nak baca. Boleh
Okay, thank you, Doktor.
You're welcome. Okay. Next one, courtesies. Okay, kalau skewness ni, it is about how does the data deviate from the left side to the right side. But this one, courtesies, is about a peakness, puncak. Okay, puncak data tu, the peak of the distribution. The rule of thumb is similar. Okay, either plus minus 1, plus minus 2, or plus minus 3. Okay, the most conservative researcher may also use plus minus 7. Ada juga yang guna plus minus 7 for courtesies. Kalau when you attend perbahaman class later on, perhaps you may see that the cut-off point that will be used by perbahaman will be plus minus 7 for courtesies. Okay, for courtesies. For courtesies, how we can read the value of courtesies? We go again to the Ibm SPSS output just now. Okay, here. So then we can see next to skewness, we have courtesies. So in this case, the courtesies value equals to 295.869, which is far beyond the plus minus 3 or plus minus 7. So based on courtesies also, we can conclude that our data are not normal. Faham? Boleh baca Boleh sama macam skewness, quite similar with skewness. Okay. Okay, so another way to determine the normality is by using the Kolmogorovsk and Shapiro statistic. Okay, Kolmogorovsk and Shapiro statistic. How we can read? It is based on the significant value. Okay, if you use the criteria based on skewness and courtesies, we read the statistic value. Okay, but for Kolmogorovsk and Shapiro we refer to the significant value. We refer to the significant value for both Kolmogorovsk and Shapiro. Okay, the criteria is if the significant value larger than alpha 0.05 or 0.01, the data considered to be normal. Okay, again, the criteria is if the significant value larger than or equals to alpha 0.05 or 0.01, data considered to be normal. Okay, if the significant value lesser than alpha 0.05 or 0.01, it means that our data violate the assumption of normality. Okay, any question? Apa ke benda pula 0.01, 0.05? Any question? Ada, tu clear You all okay dah? Risau pula semua diam, risau pula.
Sebab tak belajar stat lagi doktor.
Okay.
Jadi macam blur.
Okay, benar Sikit je ni, dia cut off point, dia statistik sikit je ni. Okay, so the alpha ni, it is referring to the confidence level. Confidence level, how we confidence about our decision. Either we want to reject or fail to reject our null hypothesis. Okay, so alpha, the most regular alpha value that we use is either 0.05 or 0.01. Okay, what does it mean by 0.05 or 0.01? 0.05 meaning that we only accept 5% error in our data, meaning that we are 95% confident that our decision is correct. Okay, meanwhile for what 0.01 is referring to, we only accept 1% error. Okay, because as a researcher, we need to know that there is no research that is perfect, 100% perfect, takkan ada. So we must set at least 1% or 5% error dalam our finding. That's why if you see any detergent, for example, detergent, kan betul kan detergent, sabun tu, sabun basuh tu, okay, in the advertisement you always can see that they say that 99.99% kill the bacteria. They never say 100%. Sebab apa? 0.001 tu they consider as error. Dia orang takkan 100% confident yang sabun tu boleh membunuh kuman. Dia orang tak akan cakap, dia orang tak akan berani cakap 100%. Because when we do any research, we always will expect that the possibility of we make any some errors, buat silap. Okay, tak kira lah error tu kat mana, either during data collection, either during the instrument test, either in our data itself, ada saja. So kita letak je error kita tu. Okay, so the alpha ni basically kita guna 0.01 or 0.05. 0.01 indicate that we only accept 5% error. 0.01 meaning that we accept only 1% error. So 1% error means that we are 99% confident that our data are correct or our findings are correct. Okay, kalau 95%, we infer that 95% we are confident that our data are correct. Itu maksud dia. Faham Soalan lagi?
Doktor, kalau dalam bentuk ayat, maksudnya if significant value tu adalah lebih besar atau sama dengan confident level data kita iaitu 5% or 1% error, maknanya itu adalah normal data.
Yes.
Dalam bentuk ayat. Oh.
Yeah. Okay, for ayat dia dalam bentuk if significant value, okay, alphas, if significant value here larger than alpha 0.05, so data considered to be normal. Ataupun for example, in this case, for example, the significant value equals to 0.83, for example. Okay, so we can conclude that since the significant value equals to 0.83, okay, which is larger than alpha 0.05, so therefore the data met the assumption of equality, therefore the data met the assumption of normality. Itu ayat penuh dia. So same goes to Shapiro wheel. The requirement is similar. We compare the significant value against alpha. If the significant value larger than or equals to alpha 0.05 or 0.01, okay, the data considered to be normal. If the significant value lesser than alpha 0.05 or 0.01, it violate the assumption of normality. Dan you all boleh tanya pula, kenapa 0.101 ataupun 0.05? Okay, it depends on the researcher, which one that you want to choose. If you are confident with your data, then you can choose the most stringent one, which is 0.01. Okay, up to you. Biasanya yang digunakan in social science is 0.05. Okay. Jadi kita dah belajar to check on the normality. We have mean, either mean equals to mode equals to median. That one is the first one. The second one is we check on the skewness and kurtosis value. The cutoff point is the most conservative is plus minus 3, but the better one is plus minus 2. Okay, for the normal based on skewness and kurtosis. But if we refer to the Kolmogorovsk, and Shapiro wheel statistic, we refer to the significant value in which we compare the value of significant A against alpha. If the significant value larger than or equals to alpha 0.05 or 0.01, so our data met the assumption of normality. If the significant value lesser than alpha 0.05 or 0.01, we can say that our data violate the assumption of normality. Okay, any questions so far?
Doctor,
yes.
Do we need to run all the tests, or we need to choose either one?
Okay, basically we choose either one. At least one that is supporting your data. Okay, but mostly at your level, at master level, because for the mean equals to mode equals to median, and the skewness and kurtosis is the most basic requirement lah. But for master level, so probably you should look beyond. Other than skewness and kurtosis, so probably you may check for the based on Kolmogorovsk, and Shapiro wheel or other types of normality test. Ada lagi, banyak sangat. Okay, as long as there is one data, there is one proof, one statistical proof supporting that your data are normal, so then you can proceed with parametric statistic. Parametric statistik ni apa? Data, bila kita nak guna analisis tu, requirement dia data kena normal. Contoh, okay, t-test. Saya rasa saya ada slide tu. Hold on, dia ada non-parametric compatible analysis. Non-parametric, hold on.
Doktor, just nak tanya,
Yes.
Means kalau the data is not normal, that means we cannot continue with the t-test, and then the hypothesis cannot be proven, and then
okay, the hypothesis
means
is
that
different thing. Hypothesis is different thing. Okay, the first thing is before we run the analysis, we need to know the attributes of our data, and then we need to know the attributes of the type of statistical that we want to use as well. Sebab nak pakai statistik ni, dia tak semua kita boleh main pakai je. Dia ada keperluan dia, dia ada requirement dia. Hold on saya cari slide tu dulu. Ni. This is the example, non-parametric equivalent test of the parametric test. So for example, in the t-test. So t-test later on you will learn lah. Ni tak ada masuk. This is not going to be in our research method final exam. This is just for the general knowledge only. It will not be included in our final exam. Okay, this is general knowledge. So jangan pening, jangan risau. Okay, so for example, okay, so the left side is parametric test, meaning that if you want to use this type of statistical analysis, your data must fulfill the normality criteria. Mesti, wajib, compulsory. Okay, so the first one, for example, t-test. To run in t-test, we have 3 types of t-test. One sample t-test, independent sample t-test, packed sample t-test. So to run the t-test, okay, you need to make sure that your data are normal. Okay, if your data are not normal, then you have option to use Mann-Whitney test or McNamara-Sign and Wilcoxon test, for example. Okay, so then our friend just now asked, if let's say our data are not normal, meaning that it will affect the type of statistical analysis. Yes, it will affect the type of statistical analysis. The second one is it will affect the hypothesis testing? No, you still can proceed with hypothesis testing. But using the non-parametric equivalent test, still boleh proceed. But in terms of explanation later, okay, probably you have limited point to be explained. Okay, when you use the non-parametric test, dia tak semendalam parametrik, non-parametric ni. Okay, so another example is one-way Anova. To run the one-way Anova, you need your data to be normal. Kalau if let's say your data are still not normal, then you can use Kruskal-Wallis. Okay, if your data, another example, two-way Anova. If not normal, you can use Friedman and Cochrane test. Another example, I thought the name ni quite famous lah, Pearson product moment correlation. Pernah dengar? Tak pernah dengar juga. Pearson product moment correlation, tak pernah dengar Okay, so biasanya kalau nak pakai analisis Pearson ni, our data bukan biasanya, wajib. Okay, when we want to use the Pearson product moment correlation to check on the association between variable, the relationship between variable. Okay, if you want to use Pearson product moment correlation, we need to make sure that our data are not normal. Okay, if our data are not normal or in categorical form, then we can consider Spearman rank order correlation. Spearman rule. Okay. Ini pengenalan sahaja. Saya tunjuk, jangan pening, jangan risau. Okay, at least you all tahu Okay, ada lagi soalan? Ini contoh je, nanti bila belajar statistik akan in-depth lagi lah. Okay. So this one, okay. So this one, when we do the quantitative study, okay, we collect we collect data from sample. Okay, when we conduct the quantitative study, we collect sample from the population. Okay, we collect sample. This is our sample. Okay, we collect sample from the population. Okay, as much as possible, when we want to collect sample from the population, we need to apply random sampling. Random sampling. Random ni macam mana? What is the example of random sampling? Random. Random. What is random? Is it when I stand at the gut house and then anybody cross me on that day, I share my questionnaire. So is it mean that it is random? Or I have apa dia?
Ya kot.
What do you understand by random?
Depends on our focus group kot, Doktor.
Population target population.
Target population. Okay.
Random tak ada target.
Tak ada target, macam mana nak buatkan data tak ada target ni? Tak boleh.
Rawak.
Rawak tu macam mana? What do you mean by random? When we mention random, what does it mean? Okay, random in quantitative study, it means that it must be strategized from the very beginning. Dia bukan random ni doesn't mean that you have one WhatsApp group that consists of officers at your office, okay, and then you want to distribute the questionnaire and then you just post the questionnaire, post the link in the WhatsApp group and you just ask for their favor for their help to fill in the questionnaire. That one is not random. Random means that you need to pick who's going to be in your population from the very beginning randomly. Okay, maksudnya for example, this is your population. So your population consists of 6,000 teachers. For example, you have 6,000 teachers. 6,000 teachers. Okay, so based on these 6,000 teachers, you need to determine how many that you need. How many? Meaning that you need to determine sample size. Okay, nanti kita akan belajar how we are going to determine the sample size. At least you know the step first. Based on the 6,000 population, first you need to identify who's going to be your population. For example, primary school teachers or secondary school teachers. For example, we have 6,000. In total, we have 6,000 primary school teachers. Okay, so based on this 6,000, you need to determine how many do you need? How many sample do you need? So then you need to determine the sample size. Okay, so later on we will learn what method that we can apply to determine our sample size. Okay, for example, okay, after we use G power, so the sample size that we need is 117 only. All we need is 117. Okay, so we need
G power tu apa, Doktor?
Nanti sekejap lagi. G power tu one of the method that we can determine sample size. How much do we need? Nanti ada lagi. Nanti saya tunjuk sekejap lagi. Okay, so for example, we need based on the sample size calculation, we need 117. So meaning that from this 6,000, we need 117. 117. How we are going to pick 117 from the 6,000? So then we need to apply random sampling. Random sample. Okay. Ni saya baru kat sini I'm only here from the population to sample. Sini baru. Okay. So one of the method that you can use to determine to select your sample is by using Excel. Excel. Ni saya tunjuk contoh direct. Hold on ni kena buka Excel pula. Okay, so this is an example our Excel sheet, which is consists of our respondent, which is 6,000 earlier. So this is population. Okay, so for example, we have 6,000. Tapi saya letak only 200 lah but in actual we have 6,000. Allah. $300 lah. Dah extend sampai 300 ni. Okay, so for example, we have 300 ni. Okay, our population equals to 300. Okay, and then based on this 300, we need 117. We need 117. One of the way to randomly pick our sample is by using Excel, which is we apply the formula equals to random open bracket close bracket. You apply this formula. Okay, equals to RAND open bracket close bracket and enter. So you have the random value. Okay, so based on this random value, you just drag until the 300 respondent up to here. Okay, it will generate unique value for each respondent. Okay, dia akan generate satu unit value untuk setiap respondent. Okay, so then we sort the value by using sort smallest to largest. Okay, so then as you can see, the numbering on the population is changed. Okay, it's already random. So then earlier, the n that we need, the sample size that we need is 170. So we pick 117 from the list. So these are the number of, these are the respondents that we are going to contact to be included, or we are going to invite to be included in our study. The respondent number 145, 47, 48, 27, 282, 124, 200, 195, 219 and so on. Faham? Dia bukan based on the one that is the most convenient to us. So this is one of the method that we call as simple random sampling. Faham? Bila sebut simple random sampling, you must apply this one. First, you need to know your population. Then you apply the random sampling technique. So this is one of the example of random sampling technique. Any question? Boleh? Pening dah? Pening dah?
Doktor, saya tak faham bila doktor sort largest to smallest tu, tapi susunan dia tak ada pun jadi largest to smallest pun.
Yes, but it depends on the system lah. Kadang-kadang sistem tu dia tak sort pun. Bila saya ubah sikit je, nombor tu akan berubah. But it's okay, we just apply the sorting tu. As long as we apply the sorting and the population on the left side, the arrangements change, okay, meaning that it's already random. Kita tak nak sebenarnya bila dia in an array dalam arrangement tu, okay, we just pick according to our preference. That one is considered bias. But if we apply this technique, even though it's not arranged accordingly, but it's already random. Random sampling means that we need to set we need to choose who's going to be in our respondent from the very beginning by applying the random technique.
Betul, setiap responden tu akan ada nombor dia ke? Nombor responden tu daripada population kita tu.
Okay, it depends on you actually. It depends on you. Dia tak semestinya. Sometimes you can use the name, the actual name, but as what we know in quantitative study or in any research, we cannot reveal the name, or even the organization will never share the name unless you are part of the organization and you know who's going to, you know exactly your population. Actually, you ada access to the data lah. Okay, you can use the numbering or you can use the name. So then you apply the same technique, then the name too will change accordingly. So then you pick lah according to the number that you need, according to the number of sample that you need in your study. For quantitative, everything too must be predetermined. Different with quali. Okay, quali ni, when you do the data collection, only then you know how much you need. Okay, how much depth you can proceed. Kalau dalam kuanti, semua kita kena set from the very beginning. Sebelum kita buat data collection, kita dah tahu dah Okay, the procedure tu macam mana, berapa yang kita nak, semua dah set. Okay, is it clear? Risau pula saya ni. Clear tak?
Doktor, the process tu macam susah lah because from the population of 6,000 tu, once you going to identify, tapi sebenarnya kita nak sampel 170, let's say kan. So should be, kita kena tunjukkan proof ke yang kita dah buat all the base calculation tadi to make sure that taburan population tu tidak bias lah.
Basically, yes, we need to indicate somewhere in our report that we already apply the simple random sampling accurately. Kena cakap. Sebab tu orang kata kuanti senang, dia tak sesenang yang kita fikir. Kan sebelum ni fikir tak apa, buat questionnaire, just distribute post in our website, okay, settle. No. Okay, because the main principle in quantitative is we want to make sure our data are representative. How to make sure representative? We cannot have any bias. How to avoid bias? Apply random. Even though there are still error, possibility for error, but we avoid the bias. Bias as a researcher, we select our sample according to our preference or according to our convenient. Okay, so nanti kita belajar lagi. Okay, okay, so done for random sampling ni. Tapi kita dah belajar belum berkenaan dengan sampling ni? Belum lagi tak? Belum. Kita baru belajar pasal design. Belum lagi. Okay. Then next one you need to remember two things. Okay. You always learn about the term statistics. Pernah tak dengar perkataan statistik, statistik kelas statistik? What is the origin of statistic? The statistic ni comes from sample. Meanwhile, any value that has been derived from the population, the name is parameters. Any value that has been derived from the population, the name is parameters. For example, my census or e-census. E-census, the study involved the whole Malaysia, right? Banci, dia melibatkan semua penduduk di Malaysia, Banci, census. Okay, if you refer to the report for e-census or Banci ni, okay, the report only use mean, median, mode, percentage and so on. Because why? Most of statistic you cannot use. Most of the statistic you cannot use for value that involve population. Statistic ni only applicable for sample. The study that involves sample. Yes,
population is not big, doctor?
For the population, doesn't matter. As long as you study the population. For example, you are interested to study your organization, which is one manufacturing organization that consists only 100 employees. And you are interested to study that 100 employees, 100 employees. Your study, if you include all the members within the organization, which is 100, the name is the name of your study is only involve population. It's not a sample study. So meaning that you only can apply a very basic analysis, not statistic. You only can report mean, median, mode, percentage. Kena faham betul-betul. Ada beza study yang melibatkan populasi dan study yang melibatkan sampel sahaja. If you remember last week when I shared about the design, okay, there is one design. The name, the specific name for one design that involve the whole population, which is census. Nama dia census. Itu je nama dia. Kalau kajian yang melibatkan keseluruhan populasi, nama dia census. Okay, if the study that involves sample, so only then we divide into few types, either experimental, non-experimental. Faham?
It means kalau the population is very small, bukankah dia tunjukkan better findings compared to samples tu?
Okay, bukan. The simple principle in quantitative study, the higher number of the sample, the closer the number of sample to the population, it always the better. Okay, itu prinsip asas dia, walaupun ada error lain lah yang akan terlibat. But as long as you study the whole members within your population, the name is census. And when you have the census study, you cannot apply statistic because statistic only applicable for study that involve sample.
Okay, faham.
Dia tak kisah walaupun populasi tu kecil ataupun besar. Doesn't matter.
As long as it's sample, as long as the data from sample, so then we can apply statistic.
Statistic. Kalau kita study the whole population, the whole unit of the population, the name is census. Therefore, we cannot apply statistic biasanya. Okay, faham So kena faham nanti apa beza statistik dengan parameter. Parameter ni the value derived from population, meanwhile statistik ni the value derived from sample. Okay? Okay. Okay, so then I introduce you to the few types of descriptive statistic. Because the purpose of collecting sample from the population, we want to describe we want to infer, we want to make inference, okay, from the sample to the population. Okay. Okay, first descriptive statistic. Descriptive statistic ini is not inferential. It's not inferential. Okay, that's why it mostly been used in population. Okay, it is not multivariate or it is not causal. Okay, the main purpose of using descriptive statistic ni, we want to describe our data, describe our finding in terms of mean, mode, median, or measure of dispersion ni, range, variance, and standard deviation. Okay, later on when in your statistic class you will learn about two types of descriptive statistic, which is measure of central tendency, MCT, which is consists of mean, mode, median, and measure of dispersion. Okay, we have range, variance, and standard deviation. 3 benda. Okay. Okay. Then ni jenis-jenis tadi lah Ini saya tak sentuh sangat lah the type of descriptive statistic ni. Okay, any question so far? Doktor, kenapa doktor kena ajar statistik dalam research method class? Because the selection of statistical analysis depending on your research design. Okay, the selection of statistical analysis in quantitative research is depend on your research design. If from the very beginning you use non-parametric research and then specific to the descriptive research design, so the highest level of analysis that you can go only descriptive analysis. Okay, nampak tak alignment dia daripada design yang kita pilih, objektif dan juga dengan data analisis yang kita boleh pakai. If in your study you choose to use a descriptive research design, the highest level of analysis that you can go when you want to present your finding only descriptive statistics. Okay, apa contoh descriptive statistic? We have we have two big category, measure of central tendency, which consists of mean, mode, median, or measure of dispersion. We have range, standard deviation, and variance. That's all. Itu saja. Ataupun sometimes you can report percentage or count, frequency. Itu sahaja untuk descriptive. You only describe your data. Faham? Dah tak faham dah? Okay. Now we learn about either it is one tail or two tail. Seko ataupun dua ekor. One tail or two tail ni, it is referring to the distribution of your data. If you recall the bell shape that I showed just now, it has two directions, either to the negative side or positive side. Negative or positive. Okay, belah kiri atau belah kanan. Okay, so one tail or two tail ni will reflect your hypothesis development later on. Okay, if let's say in your hypothesis later on, you indicate either the direction of the relationship or you indicate either which group better than another which group, meaning that you indicate the direction, the name is one tail. One tail. One tail ni means that you specify the direction. Okay. In quantitative research, we are interested to test two things at least. One, compare. We want to compare. We want to make comparison. Either group A better than group B, or they are equals, or they are either group A better than group B, or group B better than group A, or they are equals. Tak ada beza. Itu compare. Yang kedua, we are interested to look for the relationship. Dua benda. Okay. So for example, when you want to compare, you want to make comparison, you indicate you specify which group better than which group, meaning that you indicate the direction. If you indicate the direction, means that it is one tail. Okay, same goes to the relationship. If, for example, you want to determine the relationship between work engagement and job performance. Okay, so you indicate there is a positive relationship. There is a positive and significant relationship between work engagement and job performance. So since you indicate the direction is positive, so it is one tail. Faham? Faham Kalau kita indicate je tu, so itu maksudnya dia one tail. Okay. Next one, the two tail. For example, there is a significant difference between job performance. There is a significant difference in job performance between male and female employees. We mentioned about the significant difference, but we do not mention which group better than which group. Kita tak mention apa-apa. So it is two tail. Okay. Another example for the relationship. We said that there is a significant association between work performance and there is a significant association between work engagement and job performance. We mentioned about we want to look for the significant relationship, but we do not mention the direction of the relationship. That one is the example of two-tail test. Two-tail. Dua ekor. Two-tail means that we do not know either the direction of the relationship is negative or positive. One tail ni we specify. Okay, either the direction is negative or positive. How to decide negative or positive? How to decide? How to decide either it is one tail or two tail? Refer to the theory or refer to your literature. Okay, how you can propose either the hypothesis is one tail or two tail, refer to your literature. If majority of past studies indicated that the relationship is positive, so therefore you may propose a one tail hypothesis. If past study indicated none related to their direction, then you may propose the non-directional hypothesis or two tail. Okay, this one directional hypothesis. The other name for one tail is directional hypothesis. For two tail is non-directional hypothesis. Okay, any questions so far? Dia diam ni saya risau. Betul-betul faham atau betul-betul tak faham? Dua je. Okay. Inilah one tail, two tail ni. Apa? Ini laju. Okay, this one confidence interval. So this one I already explained to you earlier lah. Confidence interval or sometimes we use alpha. Alpha. So confidence interval referring to the confidence that they can have in the accuracy of their finding. How confident we are about the finding of our study. Okay, how good their approximation is and how confident they can be in inferring that the score found will be in the range or the interval of acceptable score for that result. Okay, so ini dia punya general rule. 95% confidence interval referring to we only accept 5% error. If 99% confidence interval, we only accept 1% error. Ini confidence interval alpha level tu. Rombak alpha lain, alpha. Ini alpha. Okay? Any question? Ini saya kenalkan dulu. Nanti kita akan jumpa accordingly. Okay? Next one, effect size. Effect size ni referring to the magnitude. Okay, the amount of something. Okay, it operates in two spheres, meaning that you can see the effect size ni into situation. First, when you are looking for the difference. Okay, different. For example, the difference in job performance between male and female employees. Different. Ataupun the difference in salary between three different main races in Malaysia. Chinese, Malay and Indian. Contohnya, you want to compare between these three races. Okay. The second situation, you can see the effect size ni when you are interested to see the association. Okay, you want to make prediction, for example. Okay, association or prediction. You can see the effect size. Effect size ni sebenarnya, if we know that the relationship or the difference is significant, then we want to quantify how much is the difference or how much is the relationship. Quantification lah where kita quantify. Okay. So ni the effect size, the cut-off point for the effect size yang we mostly use, which is the first one is by Cohen D. We use Cohen D. The value lesser than 0.5 indicate small effect. The value lesser than 0.8 indicate the medium effect. 0.8 and above, large effect size. Okay. This one is measure for association, effect size for the association. Okay, for example, when you use the Pearson product moment correlation or Spearman row or Spearman rank order correlation, then you can determine the effect size by using Guilford rule of thumb. Guilford rule of thumb. Pernah dengar tak? Peraturan ibu jari Guilford. Pernah dengar? Tak pernah dengar?
Baru
Tak
dengar.
pernah.
Okay.
Baru dengar.
At least dengar. Okay, kejap saya tunjuk. Peraturan ibu jari Guilford. Okay, so this is the Guilford rule of thumb. If the R value that you get is lesser than 0.2, the relationship indicate negligible relationship. 0.2 to 0.4 low relationship, 0.4 to 0.7 moderate, 0.7 to 0.9 high relationship, above 0.9 very high relationship. Okay. If you may recall saya rasa kita dah belajar dah during secondary school. What is the value, the highest value for correlation, the relationship? Tahu tak? Tahu tak? Tak tahu. Tak ingat. Okay, tak apa. Okay, when we are interested to check for the relationship, okay, we look at the relationship ni based on R value. R ni apa dia? Correlation coefficient, perkali korelasi. Okay, correlation coefficient. This is the name. You will learn in depth in your statistic class lah. Okay, correlation coefficient, perkali korelasi. Okay, so the value of correlation coefficient ni will range from 0 to 1. 0 to 1. The smallest value of correlation which is 0, which is indicate no relationship. The highest or the perfect correlation will be 1. 1. The perfect correlation equals to 1. Okay. Faham R ni the smallest value of R equals to 0, the highest equals to 1. If let's say, okay, we want to indicate the positive relationship. When determining the relationship ni, there are 3 types of relationship. Okay. Kalau belajar ingat secondary school dulu. If we have one linear like this, okay, this indicate what type of relationship? One increase, X increase, Y increase. What type of relationship?
Direct relationship.
Direct and positive.
Positive.
Positive relationship. Positive relationship ni means that increase one unit increase in X, Y also will increase by certain unit. Increase X increase, Y increase. So this is a positive relationship. What about this one? Increase in X, Y decrease.
Negative.
Negative. Negative relationship. Okay. What about this one? What about this one?
Lupa tak ingat.
No relationship. No relationship. So the first one is positive relationship. Y increase, X increase, Y increase. X ni indicate our IV, independent variable. Y indicate, Y denominates our DV. Sama. So X, Y. So if X increase, Y decrease, this one is negative relationship. But if there is no changes for any no changes of X of Y value when X change, okay, so this is no relationship. No indicate 0. Okay, boleh. What about this one? What about this one? What about this one? What is the direction of the relationship?
Still positive.
Positive. So meaning that either it is at the positive side or negative side. The direction ni positive ni, walaupun dia duduk kat bawah tapi the relationship is still positive. Okay, positive positive walaupun dia dekat bawah. Okay, walaupun dia dekat bawah ni. So we can see the increase in Y when X increase. Okay, X increase ni ke sebelah kanan ni, Y pun increase. The value of negative tu decrease. Okay, clear So ada 3 jenis hubungan. There are 3 types of relationship. No relationship, negative relationship and positive relationship. Okay, dalam jenis hubungan ni ada 3 jenis. Okay. Okay, next one. Tadi the first one is descriptive statistic. The purpose we use descriptive statistic is to describe the variable in terms of mean, mode, median or standard deviation, variance and range. Itu contoh untuk inferential statistic. Descriptive statistic. Next one, inferential statistic. So first, please remember when you apply descriptive statistic, you do not have any hypothesis to be tested. Okay, untuk objektif yang melibatkan, for objective that only involve the description, for example, to determine the mean or the level, you do not have any hypothesis to be tested. Tak ada hypothesis, tak ada pembentukan hypothesis. Hypothesis only applicable when you start to know about the inference, when you want to make inference. Okay, when you start using the inferential statistic, only then you should think about hypothesis development. Okay, bila melibatkan dua benda yang kita nak kaji, perkaitan dua benda, ataupun you want to compare between two groups, only then you should think about the hypothesis. Okay, so inferential statistic, the main purpose of using the inferential statistic is we want to make inference or prediction based on the data gathered from the sample to the population. We want to make inference, we want to make generalization from the sample to the population. This is the main purpose of using inferential statistic. Okay, they infer or predict population parameters or outcomes from sample statistics based on probability. Okay, the main interest of using inferential is we want to make inference from the sample to the population. We want to make prediction of the population parameters based on the outcomes or based on the finding that we receive from the sample. Okay, so that's why inferential statistics include hypothesis testing. Okay, so please remember in statistics, the highest level of analysis is regression and multiple regression. After regression, there is no more statistical analysis higher than that. Okay, paling tinggi, analisis yang paling tinggi dalam statistik adalah regression. Regression. Lepas regression tak ada dah. Okay, lesser, lower sikit daripada regression, we have correlation. Bawah sikit pada correlation, we have difference in testing. For example, t-test and Anova. Anova ni stand for analysis of variance. Okay, analysis of variance, Anova. Okay, bawah sikit kita ada factor analysis and structural equation modeling. Bawah lagi, the most basic one we have descriptive statistic. Descriptive statistic ni statistik yang paling lemah in academic but the most powerful analysis in practice. Betul tak? Kalau dalam UR ada report correlation tak? Ada tak? Ada? UR report tak? Tak ada. UR report deskriptif saja, percentage, mean, mode. That's all. Tapi you all boleh tambah lagi lah sebenarnya buat cross tab. Contoh kalau nak buat report. Okay. So inferential statistic ni is more powerful compared to descriptive statistic lah. It is more powerful. Okay. But dia depends on the area lah. Depend on practice. Biasanya memang jarang pakai benda-benda ni. Okay. Biasanya dalam akademik je kita nampak. Okay. So these are the types of inferential statistic. For example, you are interested to check on the comparison. Compare. Just now I said that if you are interested to compare between two groups, if you are interested to compare between two groups, we have one analysis which is t-test. T-test. Nama dia t-test. Ujian T. Okay. When you want to apply the t-test, you must have two group at least. Okay, macam mana kita nak bandingkan kalau kita hanya ada satu kumpulan tak? Betul tak? Mesti ada dua benda yang sekurang-kurangnya dua benda untuk kita bandingkan. Dan if you want to apply the t-test, you only should have two group. Two group. Cannot be less, cannot be more. Only two. Okay. The first type of t-test is one sample t-test. One sample t-test. Okay, sini kena bagi perhatian betul-betul. One sample t-test ni we apply when you only conduct or collect the data from one sample. Okay, you only collect the data from one sample, then you compare the finding that you receive from this one sample to the standard value that has been published as well elsewhere. Contohnya, we want to compare between the volunteerism index in Malaysia with the global index, contohnya, ataupun industrial harmony index in Malaysia with the global index. So the global index ni has been posted, for example, by ILO. Contohnya, ILO dah post the global index for industrial harmony index ni, for example, 0.8. 0.8. Dia dah publish secara standardnya 0.8. So then you conduct one study in Malaysia to study on industrial harmony index. Then you determine that the value is 0.6. So the value that you receive from your current study 0.6, you compare against the global index, which is 8. 0.88. 8 tadi. Faham? One sample t-test ni maksudnya you only collect your data to one group sahaja. Then you compare against the standard value. Faham? Faham? Tak faham? Pening dah. Faham? Saya habiskan sampai sini je ni. Nak habiskan sampai sini. Boleh?
Boleh.
One sample t-test faham? Clear? One sample t-test.
InsyaAllah.
Okay, the second one is independent group t-test. Independent group t-test ni, you have two groups. Okay, you are interested to study job performance between two groups, male and female. Two groups, male and female. Okay, which is the two groups ni are independent. Dia tak berkait. Independent. Lelaki berkait tak dengan perempuan? Tak berkait kan? Perempuan tak berkait dengan lelaki kan? They are two independent group. Okay. Okay, so you have two groups. So then you collect the data for job performance for male, and then you collect the data for job performance among female. So then you compare the result. You compare the mean. Okay, so then this comparison, the name that you test for the two independent group, the name is independent sample t-test. Faham tak? You bezakan dua group yang tak berkait. Faham Faham tak faham? Tadi
yang one sample test tu, kalau dia ada dua, that means automatic dia akan jadi independent group test lah.
Okay, kalau dia ada dua, maksudnya kalau dia ada dua kumpulan yang kecil lagi, dia boleh jadi independent. Kalau kita nak, if you want to divide again, one sample tadi tu based on male and female, it can be independent. But I just want to make sure that you understand about one sample tadi tu. What is one sample? One sample ni means that we only collect, yes.
One sample tadi only collect the data from one sample and compare
against the standard value. The standard value ni already published elsewhere. Dah ada dah. Kita tak payah cari. Okay. Kita ada yang value kita conduct satu study sahaja, we compare against the standard value. Okay. For example, Industrial Harmony Index for whole Malaysia dah ada satu. We have one index for whole Malaysia. But now you want to study, you want to collect the Industrial Harmony Index in Kedah. So then you conduct the study, you collect data in Kedah. So that you got the value, then you compare against the Malaysian overall index. Itu maksud dia. Yang overall tu kita dah tak payah collect, dah ada. So kita compare sahaja. Okay, itu one sample t-test. Two sample, you have two group, and then you still need to collect your data among the two groups, male or female. You use similar instrument. Okay, you can collect the data simultaneously at the same day, at the same time. But you only involve two groups.
Kalau contoh industrial harmony tadi, kalau kita buat few states.
So industrial, kalau in the case of industrial harmony for the independent group ni, so then you want to know the differences in terms of perception of harmony between male and female. Boleh?
Okay.
So then you compare. You tak compare dengan the standard index dah, but you compare between the result for male and female. Faham?
Kalau compare between different state?
Different state pun possible. Boleh jadi. But only two. Only two. Cannot be more. The number of group only two. Two. Tak boleh dua. Tak boleh lebih. Faham Kedah, you want to compare with Perak. Or Kedah with Perlis. Contoh. Boleh? Two groups only. Okay. The next one is dependent group. For dependent group ni, you imagine you conduct one training. The easiest example is training. Okay, you conduct one training. So before you give training, you collect the data to the rest. You have one group of respondent, one group. Okay, for example, you want to conduct the training on on competency amongst primary school teachers. So you have 30 primary school teachers. Before you run the training, you distribute the questionnaire, you distribute the instrument. Okay, then you conduct the training, which is you do the treatment. Okay, and then after the treatment, after completed the training, you distribute the questionnaire again. So then you compare the result before and after.
Pre and post lah kan?
Pre and post. Pre and post. Ini untuk the name is dependent sample t-test, which is the first group and the first result and the second result ni depend with each other. Dia ada perkaitan ni. Kalau hak ni dia tak ada kaitan. Hak ni dia ada kaitan before and after. Faham
Doktor, dependent tadi tu maksud dia macam kita buat pre-test sebelum kita pergi kursus.
Sebelum kita dengar kursus tu, kita jawab dulu soalan. Okay, kepahaman kita tentang topik tersebut. Then kita attend kursus, dengar. Lepas dengar, okay, then dia bagi lagi suatu
post-test.
Dan post-test. So then result tu kita bandingkan.
Okay.
Itu adalah dependent group t-test. Ada lagi soalan? Nampak dah nak masuk ni, pukul 8 lah ni. Solat maghrib belum lagi. Okay.
Kalau macam kita punya dissertation kita, doktor, one dependent and based on 2 atau 3 parameters, dia masuk dalam kategori mana?
Again, lagi sekali.
Kita punya dissertation tu.
Okay.
Kita ada satu dependent variables.
Satu dependent lagi 2, 3 IV. Itu boleh jadi bawah lagi satu. Ini for example, in your study you want to know the influence or probably the influence of gender. Gender. This is your DV job performance, for example. You have this is framework job performance. This is your IV, the first IV, and then you have second IV, which is work engagement. Next one is flexi work arrangement. Contoh. So this is your model, for example. Okay. So for example, gender ni, if you want to compare the job performance between gender ni, so this is the possible analysis that you can use. Faham? Nampak tak? Daripada design, research design, okay, research analysis, the construction of research objective, and then the selection of statistical analysis. Sebab gender ni dia group, dia satu variable je. Dia satu variable, cuma ada dua group, dua kumpulan. Faham Nampak dah sikit-sikit macam mana nak buat framework ni? How you are going to draw your framework?
Faham sikit-sikit.
At least nampak sikit-sikit, alhamdulillah. Saya tak expect you all faham sepenuhnya pun. Okay, throughout the way, insya-Allah. Along the way. Okay? Faham
Buat faham kot, insya-Allah.
Buat faham, jangan buat faham, bahaya. Kalau dah buat
bukan
faham,
kalau kita buat tu kita faham lah kot.
Okay, alhamdulillah. Okay, the last analysis for comparison is Anova. Just now we learned about the type of statistical analysis when we want to compare two groups. But now, if you are interested to compare between a group more than 2, the number of group is more than 2, which is race. Okay, you want to compare job performance between 3 different races in Malaysia. Malay, Chinese and Indian. 3 kumpulan. Okay, kalau perbezaan melibatkan 3 kumpulan sahaja, please remember one way Anova. Okay, one way Anova. Kenapa one way? Sebab kita hanya bandingkan satu IV dengan DV. Okay, we have only one factor. For example, race. But if you have 2 categorical factor, for example, race and gender, it can be two-way Anova. Your DV still maintain a job performance, but you have two categorical variable. Okay, you have gender and then you have race. Okay, dia macam you all imagine cross tab, you all buat cross tab, tapi dia ada lain sikit.
Dr. Anova ni sampai berapa kita boleh buat?
Sampai berapa? Sampai infinity. But for human logic, biasanya up to 3 only. Up to 3 categories. For example, we have gender, we have race, and then we have possibly we have economic status. For example, 3 cukup. Beyond that, it is beyond more than that, it is beyond human interpretation. Lebih daripada 3 susah dah. Saya cadangkan sampai up to 3 sahaja cukup. Maksimum dah tu. Kalau tak susah.
Maksimum 3 lah.
Maksimum 3. Okey, ingat
Contoh kalau kita contoh doktor, kalau 3-way ANOVA tu kita buat gender, race, lepas tu state, boleh ke?
Possible?
Macam tu lah kan.
Okay, so remember, if you were interested to compare between 2 groups, you have t-test. If you are interested to compare more than 2 groups, we have ANOVA. Okay, analysis of variance. Okay, nak proceed lagi ke kita nak stop? Nak proceed lagi solat dulu ke macam mana?
Solat dulu, Dok.
Solat dulu.
Solat dulu kot.
Solat dulu, lepas tu kita sambung balik Boleh?
Yes, boleh.
Kita jumpa balik.
Boleh.
Pukul 8.20 boleh? 8.20.
Boleh.
Okay, so
boleh,
you in 15 minutes. Okay.
Okay, thank you, Dok.
Thank you, Dr.
Okay, ready? Boleh? Dah ada ke? Tengah solat lagi?
Ada.
Okay, boleh proceed dah Okay, now. Okay, proceed. Okay, now. Okay, so now I will introduce you to the hypothesis, how to develop the hypothesis for differences. Okay, how to develop the hypothesis for differences. Okay, so there are two types of hypothesis. Okay, kita dah belajar kan dua jenis hypothesis dah. Null hypothesis and research hypothesis. Dah belajar belum? Saya pun lupa dah. Dalam slide lepas ada tak? Two types.
Ada.
So two types of hypothesis. Last time we learned about the two types of hypothesis. Hypothesis, null hypothesis and research hypothesis or alternative hypothesis. Okay. So if you want to develop the hypothesis for differences ni, again, which hypothesis that we as a researcher interested to? Null hypothesis or research hypothesis? As a researcher, which type of hypothesis that we are interested in? Mana satu? Null hypothesis or research hypothesis?
Research hypothesis.
Okay, so as researcher, we are interested to prove or we are interested with the research hypothesis. But the hypothesis that we test is the hypothesis yang kita uji. When we conduct the study, the hypothesis that we test is the null hypothesis. As a researcher, we are interested with research hypothesis, but when we conduct study, we test the null hypothesis. Okay? Why null hypothesis? Kenapa kena ada null hypothesis? The principle that we apply is similar the principle that applicable in legal area, okay, which is someone is not guilty until he is proven guilty. Seseorang tu dianggap tak bersalah sehingga dia terbukti bersalah. So itu kita ambil prinsip yang sama, kita apply kat sini. Okay, that's why kita test the null hypothesis. Okay, so example of hypothesis for difference. For the research hypothesis, there is a statistically significant difference between male and female students in the result of research method. Contoh, ini hypothesis perbandingan. This is one tail or two tail? One tail or two tail? There is a statistically significant.
Male and female. Male and female.
Why two tail? Because
Two groups.
because two groups, lagi satu, we do not mention which group better than which group.
Positif.
Kita tak ada mention mana-mana kumpulan lagi bagus daripada mana-mana kumpulan. Okay, we does not mention the direction. Ataupun we do not specify which group better than which group. Tak ada, kita tak specify apa-apa. So itu adalah two tail. This is the example of two tail research hypothesis for difference. The null hypothesis will be there is no statistically significant difference between male and female students in the result of research method. Ini contoh how you want to develop the hypothesis for difference. Okay. Next one. Okay, the second type of inferential statistic, which is association. We are interested to see the the association between two or more variables. Okay, two or more variables. Okay, as what we learned just now. Okay, there are two types of analysis that we can apply to test for the association. If your data met the requirement of normality, then you can use Pearson product moment correlation. If your data met the normality assumption, you can use the Pearson product moment correlation. Okay, so product moment correlation, Pearson product moment correlation coefficient ni, Pearson product moment correlation analysis we use to assess the nature of the association between two variables. We want to assess the nature of the relationship or association between two variables. Okay, when I mention the nature of the association, please remember two things. Okay, when I mention the nature of the association, remember two things. You want to describe in terms of direction of the relationship, either it is positive or negative. The second one, you want to describe in terms of the magnitude of the relationship. Satu, arah hubungan. Bila kita sebut je the nature of the relationship, we want to explain. The first one, we want to explain the direction of the relationship. Either the relationship is negative or positive. Okay. The second one is the magnitude of the relationship. How much is the relationship? How to interpret? From the R value, from the correlation coefficient value, we refer to the Guilford rule of thumb table. If the value within the particular range, then we come up with the specific, or we interpret the value accordingly. So for example, R equals to 0.65. R equals to 0.65. Which is falls within the range of 0.4 to 0.7. So therefore, we can conclude that the relationship is moderate. Faham macam mana nak baca table ni? For example, we have the correlation coefficient R equals to 0.65. So based on the Guilford rule of thumb table, so the value falls within the range of 0.4 to 0.7. So therefore, we can conclude that there is a moderate relationship between the two variables. Faham dua benda where kita nak assess the nature of the association. Two things in terms of the direction. The second one is in terms of magnitude of the relationship. Magnitude or the size of the relationship. Okay. Remember also correlation does not imply causation. Okay, it does not imply causation. When we apply the correlation, we cannot say that IV influence DV. We only can conclude that there is association between IV and DV, but we cannot determine the flow or direction of the influence. Kita tak boleh concludekan IV ni sebenarnya mempengaruhi DV. IV ni can predict DV. No. We just can say that A is associated with B. For example, Nurwanis hari ni malam ni pakai tudung color hitam. Okay, Nuraida saya tak pasti. Tapi mungkin Nurwanis pakai tudung color hitam ni sebabnya ada associated with Aida. Contohnya. Tapi kita tak boleh kata Aida yang mempengaruhi Nurwanis sekiranya kita guna analisis Pearson. Faham? Itu limitasi dia. We can describe in terms of direction of association, either relationship is positive or negative. We can describe in terms of the magnitude, but we cannot conclude the flow of the influence. Sama ada A mempengaruhi B tak boleh. Ya, Syaril.
Kalau there is no relationship between the two?
There is no relationship between the two, meaning that we assume that R equals to 0 lah. Tak ada hubungan positif negatif, that one tak ada hubungan langsung. Sometimes ini nasib baik Syaril tanya. For example, when you figure out after you run the analysis, then your result is R equals to 0.10. My question, the first question is there any relationship? Ada hubungan tak?
Yes.
Ada. Dia ada hubungan. But the relationship is probably not significant. Hubungan ada. As long as the R value is there, meaning that the relationship is there. The relationship, the association is there. But it is not significant. Biasanya tak ada. Jarang yang you akan jumpa yang 0.000. In social life tak ada. Ada hubungan, cuma dia tak signifikan. Faham Okay. So we describe the association ni through the Pearson R or Pearson correlation coefficient. Ni nama dia perkali korelasi R. Nama dia kita describe to determine the association ni, to interpret the association ni, we describe by the index. The name of the index is Pearson R or Pearson correlation coefficient, perkali korelasi Pearson. Okay, a correlation coefficient is a statistics that quantifies the extent to which two variables X and Y are associated and whether the direction of their association is positive, negative, or 0. Okay, so the R value range from -1 to +1. The highest is 1, the smallest is 0. Negative, positive just indicate the direction of the relationship. That's all. Okay, negative, positive just indicate the direction of the relationship. 0 or the value tu, the number tu indicate the magnitude of the relationship. Okay. Okay, the second non-parametric compatible analysis for testing correlation is we have Spearman rank order correlation or Spearman row. Nama dia sama Spearman row ataupun Spearman rank order correlation. We denote as RS. RS ni perkali korelasi Spearman. Spearman rank order correlation coefficient. Nama dia. Kalau Spearman tadi Spearman correlation coefficient. Kalau Spearman ni Spearman correlation coefficient. RS. Okay, so Spearman rank order ni it is a non-parametric test. Non-parametric test. We use this analysis if our data are not normal. Okay, there are dua condition where we can use the Spearman rank order correlation. The first one, if we have our IV and DV in either interval or ratio scale of measurement, but they do not meet the assumption of normality. So then we can apply the Spearman rank order correlation. The second option, okay, the second reason why we use Spearman rank order is because we have ordinal data. Our DV.
Sorry doktor, ulang yang tadi, yang first tadi.
Mana? Saya laju laju. Okay. Yang first saya recall balik yang first kenapa kita pakai. Okay, why we may consider to use the Spearman rank order correlation. There are two situations. The first situation is, okay, if we have IV and DV, Okay, the scale of measurement for our IV and DV is ratio or interval. Okay. Both our IV and DV are in ratio or interval scale of measurement, but one of them, at least one of them, does not meet the assumption of normality. For example, our DV is not normal. Based on skewness, kurtosis, Kolmogorovsk, Shapiro, our data are not normal. Okay, so then we have to use Spearman rank order. Okay, our data are in scale, the scale of our data are in ratio or interval, but one of them are not normal. Okay, so therefore we have to use Spearman rank order correlation. Boleh? Okay, the second reason, the second situation why we have to use the Spearman rank order correlation is because our IV and DV is in ordinal data. Ordinal, categorical. Dia categorical and has ranking order. Numbering tu start, numbering have logical meaning. Okay. Kalau IV dengan DV kita in categorical, which is in nominal scale of measurement, then we have to use Spearman rank order correlation. Faham Dua situasi. Tadi kalau kita ada data interval or ratio tapi tak normal, salah satunya sekurang-kurangnya salah satunya tak normal, so kita terpaksa guna Spearman rank order. Lagi satu, kalau IV dengan DV kita scale of measurement dia adalah nominal, so then kita kena guna Spearman rank order. Okay, so the RS value a Spearman rank order correlation coefficient ranges from -1 to +1. Sama juga, the lowest correlation is 0, the highest is 1. Negative plus plus minus just indicate the direction of the association. Okay, so how to interpret the value? We refer to the Guilford rule of thumb. So if let's say RS equals to 0.71, so it's fall within the range of 0.7 to 0.9, it indicates the height relationship. Boleh? Senang tak? Okay.
In terms of value tu doktor sama je kan macam yang previous.
Guilford, in terms of value sama. Guilford, for the Guilford rule of thumb, we can use to interpret the RS as well as the R. The coefficient for Pearson as well as the coefficient for Spearman. Dua-dua sama. Okay. Okay. The next one, the next types of inferential statistic, we have simple linear regression. Why simple? Because in simple linear regression, we only have one IV, one DV. The scale of measurement for IV and DV are either interval or ratio, and then to run this analysis, it must meet both of your IV and DV must meet the requirement of normality. Wajib. To apply simple linear regression, okay, your data must fulfill the normality requirement. The scale of measurement for both IV and DV are either interval or ratio. Okay, and simple linear regression is an extension to Pearson product moment correlation. They extend. Dia bila you run the simple linear regression ni, kita boleh provide more explanation on our finding rather than we just explain on the association. Now we can determine the flow of the influence, the flow of the relationship. We can confirm either IV influence DV or not. Okay, it involves examining changes in the level of Y relative to changes in the level of X. Okay, so the purpose of using SLR, simple linear regression, which we want to determine the relationship between the two variables, okay, IV and DV, and then we want to make prediction. Kalau dalam practice, we call it as forecasting. Forecasting, nak buat forecasting. Okay, which we use the equation Y equals to B0 plus B1 X1. Apa dia pula dah B1 X1? Okay, this one, if you recall, okay, the syllabus in our secondary school, this graph, X, Y. Ni. Okay, Y equals to MX plus C. Tipu kalau tak ingat. Tipu kalau tak pernah jumpa. Betul tak? Y equals to MX plus C. So what is C? Pernah kan?
Doktor dulu A equal to BX tambah C.
So
saya YM lah.
Ya, saya dulu hak ni. Y equals to MX plus C. Saya dulu hak ni. So dia sama. C, what is C? What is C? Sudah hamda pula dah. C is the value where the straight line touch the y-axis. The value here. The value where the straight line touch the y-axis. Ini adalah C. This is C. The value where the straight line touch the y-axis. Okay, so B naught ni sama. C equals to B naught. B naught equals to the value where the straight line touch the y-axis. So ni equals to B naught. Okay, so what is M? Slope. Kecerunan. Slope. If you may recall the theorem Pythagoras. Saya tak ajar, saya cuma ingatkan balik je. Theorem Pythagoras. 2 kuasa 2 tambah 3 kuasa 2 sama dengan 5 kuasa 2. Betul tak? Hak tu.
4, 5, 6, 8, 10.
Kan anak kita kan tengah duduk sama tu. Theorem Pythagoras. Gores pula. Bukan Gores dah menang. Okay. Theorem Pythagoras. Okay. So ni sama. So the equation will be y equals to b naught plus b1 x1. Okay. So b1 x1 ni will change according to the number of our IVs. So for example, in our model, we have only one independent variable. So it will stop at x1. Okay. Kalau kita dalam model kita ada hanya satu IV, so B1 X1 je lah. Okay. B0 ni akan sentiasa ada constant. Kecerunan, y-axis ni. Okay. Clear B1 ni slope. Kecerunan. Okay. Okay, so this is the example of hypothesis for relationship. Okay, so by default ataupun in general rule, we can just state that H1, our research hypothesis of the relationship, or hypothesis of existence of the relationship, the null hypothesis, no existence of the relationship. That's all. Example, our research hypothesis, we state as there is a statistically significant correlation between supervisor support and employee job performance. Contoh, this is directional or non-directional?
Ilya.
Directional or non-directional?
Ilya, sini.
Dia panggil siapa pula dah? Izian panggil siapa tu? Izian ke siapa dah?
Syahira kena mute.
Syahira panggil siapa Syahira? Okay.
Sorry doktor. Anak saya melilo jap.
Okay, so there is a statistically significant correlation between supervisor support and employee job performance. So two tail or one tail? Directional or non-directional?
Significant correlation.
Directional or non-directional? Ramzi? Saja nak sebut.
Non-directional kot.
Non-directional because we do not indicate the direction of the relationship. Okay, so our null hypothesis probably will be there is no statistically significant correlation between supervisor support and employee job engagement and job performance. Sorry, very easy. Okay, senang je Okay, that's all. Sampai simple linear regression sahaja. Okay, ada soalan?
Doktor, nanti final keluar macam ni ke doktor?
Sikit je lah, sikit. Dia takkanlah keluar banyak. Dia macam contoh probably lah. Probably if you are interested to use the descriptive research. So what is the highest level of analysis that you can proceed? Contoh. So that you can see the alignment between your research design with the type of statistical analysis that is applicable according to that particular research design. But dia memang kena align daripada awal, kena tally. Okay, kita punya research objective, our research design, as well as the type of statistical analysis that we are going to use for the quantitative study. Kena align. Okay? Lagi ada soalan?
Doktor, nanti boleh share balik recording ni, Doktor?
Boleh. Hak minggu lepas saya tak share lagi. Masya Allah.
Thank you.
Dalam YouTube dah ada, Doktor?
Belum. Belum ada dari YouTube. Okay, kita masuk kualitatif sikit sempat kot, insyaAllah. Slide kualitatif tak banyak.
Dalam Putra Blas dah ada kan, Doktor?
Dalam Putra Blas nanti saya cek balik esok, lupa. Minggu ni penuh sikit. Minta maaf sangat-sangat minggu ni. Duduk.
Dalam Putra Blas belum lagi.
Minggu ni
belum ada lagi.
Minta maaf minggu ni saya duduk pulung kurikulum. Okay, so we proceed with the qualitative research approach. By the way, do you have any question related to quantitative research approach? Make sure when you start writing your chapter 3, you specifically indicate the research design, the research paradigm, and the research design that you use according to your research objective. Then provide justification why you choose that particular design. Kenapa? Kena indicate dalam bab 3. Okay? Okay. So this is our LO at the end of the session. So you should be able to determine the qualitative research assumptions and characteristics. Okay, differentiate between different types of qualitative research design. Okay. Okay, these are the assumptions of qualitative research. Okay, first, realities are multiple, constructed, and holistic. Reality is socially constructed. Ini dia punya prinsipal dia. Realities are multiple. Kalau in quantitative, realities are single. Maksudnya we are interested with the similarities, not on the differentiation between individuals. Kita tak minat dengan kepelbagaian. Kita minat dengan persamaan dalam kualitatif, kuanti. But in qualitative, we are interested with multiple realities. Kita kena faham when we conduct the qualitative, we might look for the differences, perbezaan. Okay, the researchers, those of the individuals being investigated, and the reader or audience interpreting the result differently. Okay, researcher ada dia punya own point of view, the individual ada dia punya point of view, the reader or audience also got their own point of view. Okay, so multiple perspective including voices of informants are included in the study. So we are interested to look for deviation, for the deviation, for something that not yet been figured out previously. Okay, knower and known are interactive, inseparable, meaning that the researcher interact with those under study and actively work to minimize the distance. In quantitative study, researcher cannot influence the respondent, but in qualitative study, as much as possible, researcher need to have close relationship with informant so that they can look or have the in-depth finding. Okay. Based on my previous based on last time I learned about there is one researcher from UM. He is interested with orang asli, origins citizens in Malaysia. Okay, then what he did was he go there, he stay there dekat rumah panjang tu for years until he married anak ketua rumah panjang. Nak cakapnya betul, nak really close to our respondent. Okay, semakin close dengan kita punya respondent, semakin banyak yang kita akan dapat. Okay, so inquiry is subjective, value bound. Maksudnya inquiry kita tu dia subjective. The phenomenon under study is subjective. We cannot quantify, we cannot objectify it. Okay, researchers explicitly recognize and acknowledge the value ladder nature of the research. Okay, meaning that the researcher must admit, okay, specific the phenomenon under study ni should can be influenced by the nature, by the by race, by culture, and so on. Okay, the primacy of subject matter research is context bound. Maksudnya kena ada, that's why kena ada satu konteks yang kita setkan. Research is based on inductive forms of logic. It is inductive. Variables are complex, interwoven, and difficult to measure. That's why it is impossible to translate in the quantifiable form. Okay, categories of interest may emerge from informant or be used to frame the understanding. Okay, uncovering pattern or theories that can help to explain a phenomenon of interest in the goal, and then determining accuracy involve verifying the information with informant or triangulating among different sources information. Okay, so dalam qualitative, how we can determine the quality of our data by applying the triangulation. Triangulation meaning that we check our data from different sources. For example, we conduct the interview. That one is the first way to collect the data. Second one, we refer to any report, any available report. Probably the third one, we check our field note, buku nota. The fourth one, probably based on our observation. Interview dengan observation, two different thing. Interview ni meaning that we conduct the interview. Observation ni means that we have another session, we go to the field, we observe. Kita duduk, we sit and observe their activities. Okay, the purpose of qualitative study in general is for contextualization. Okay, nak study context, only time and context bound working hypothesis through ideographic statement, and then we want to make interpretation. Okay, understand actors' perspective. We want to understand the phenomenon or the situation based on the informant perspective. Okay, approach. So the approach ni, the qualitative approach may end with hypothesis or grounded theory. It can be the basis for the next quantitative study, or at the end of the qualitative study, you may propose a new grounded theory, a new theory. Okay, emergence and portrayal, researchers as the instrument. In quantitative study, the main instrument can be the questionnaire. But in qualitative study, the main instrument is the researcher himself or herself. Instrument tu, researcher tu yang jadi instrument. Okay, sebab tu researcher ni betul-betul kena faham responden dia, siapa informant dia. Researcher kena ada skill, kemahiran interview, probing, okay, empathy and so on, supaya dia dapat apa yang dia nak. Okay, naturalistic or non-intervention, it happen in natural setting without any intervention. It is inductive. We are interested to search for pattern. 6 for pluralism, complexity, makes minor use of numerical index, and then descriptive write-up. It is more on describing the phenomenon. Okay, then sometimes yes.
Probing is when we want to seek for more information from our informant.
Yeah.
But then probing in Malay.
Probe dalam Malay apa?
Saya cuba cari 2-3 hari ni probing in Malay. I cannot find probing in Malay macam.
Probing
and also grounded theory.
Grounded theory ni grounded theory is teori asas ataupun asas untuk pembentukan teori yang lebih kukuh. Sebelum teori itu, teori in quantitative study, okay, teori in quantitative study, it has been tested for several times until it is proven that the theory is correct. But grounded theory ni, we just propose a basis for a new theory. Itu grounded theory. Grounded yang baru lagi. Dia boleh jadi betul, boleh jadi tak betul. Faham tak? So kita akan test lagi grounded theory. Probing ni dia macam satu teknik yang bila kita interview, when kita interview ni, teknik kita tu, okay, itu one of the technique. We repeat we repeat what the respondent said to show that we are listening to them. Faham tak? To make sure that they are comfortable with us.
Dapat tu maksudnya macam, so probably we want to have more information from our informant. Malay punya term probing saya tak
ada. Saya rasa probe je. Cuba apa tu? Elwal check dekat
menyiasat.
Apa dia?
Menyiasat.
Bukan menyiasat. Probe. Cuba Elwal tengok dekat saya tengok.
Memperhalusi,
memperhalusi.
Mendalami,
memang guna bahasa Melayu
saya menyokong hasrat kerajaan untuk menggunakan bahasa Melayu. Sebenarnya susah tulis bahasa Melayu.
Baik.
Saya tahu sangat kena faham betul-betul pasal baru boleh tulis. Kalau tak apa-apa begini.
Penggalian data ke?
Boleh jadi penggalian data. Betul-betul. Rasanya penggalian data. Menyelidik bukan.
Helwa BM Helwa?
Yes, nak support kan kerajaan baru-baru ni kata we kena guna bahasa kebangsaan.
Bagus sangat. I support that. You know what? This one selingan Okay, university, okay, lecturers in bahasa really difficult for them untuk naik pangkat. Sangat susah. Susah sangat.
Sebab Dr. Nomi? Sebabnya?
Because most of the requirement for promotion, we need to publish articles in Scopus. Okay, most of Scopus articles are English.
Okay. Yes.
Very difficult to find Scopus article in Malay. Sebab Scopus article ni based on Western punya culture. Even Oxford ke Cambridge pun didn't follow that actually. Yes. Tapi macam mana? Where is the location for the academic for language?
Malay language.
Yes, Malay language lecturer to publish the article. Dia sebenarnya di tanah Melayu pun dia tak recognize. Sian.
Sepatutnya kena ada kaedah lah to recognize. Sebab kita bahasa kebangsaan. I don't want to cakap bahasa Melayu, bahasa kebangsaan kan.
Yes.
Tapi Dr. Nomi, to be honest, it's very difficult to write in Malay lah untuk tema, untuk dapatkan perkataan.
Susah, betul. Saya pun tak cakap saya pandai. Helwa lagi lah, dia punya English very good. Tapi kadang-kadang bila nak guna term tu, kita tak jumpa term bahasa Melayu tu.
Ya,
tapi saya rasa betul,
English saya pun tak bagus. Menggali data. Thank you Aida.
Menggali data, betul.
Menggali tu macam menggali kolam.
Dia kaedah menggali data. Menggali data. Dia memang term dia tu. Kaedah menggali data. Term. Nanti kalau saya jumpa yang lagi cantik, nanti I will share. Okay. So these are the rules.
Thank you.
These are the rules of researcher in qualitative study. First, personal involvement and partiality. Memang tak boleh nak partiality pun. Cuba tapi tak boleh. Personal involvement, empathic understanding, emic, which is insider's point of view. Probably during the interview tu, you should embed your own view, so you can share during the session. Okay, so in qualitative study, the role of the researcher in the position of an observer. To uncover reality, the researcher must use the power of observation to clarify and give meaning to the phenomena being studied. Kena semua during the interview, you should use all the panca indera. Okay, listening, observing, okay, probing, talking, body language, Okay, make sure your informants are comfortable with you, the setting of the interview room. Okay, that's why most of the interview or researcher may choose the setting that is comfortable to the informant. Okay, and then qualitative researchers develop a broad research question, okay, of or area of focus based upon their observations, reading or experiences in the research setting. Okay, so qualitative researcher develop specific question to help guide his or her observation. The name of this one, the interview guide, the name is research protocol. You have your research question, similar to research objective in quantitative study. So in qualitative study, you do not have objective. Biasanya tak ada objektif. Okay, saya tak tahulah kod-kod tiba nanti ada yang minta objektif. Kadang-kadang ni macam-macam. Okay. Okay, biasanya kita tak ada objektif, research objective for qualitative study. Okay, because we rely on the research question. Okay, then to help you during the interview session, you will develop a specific question, which is the name, we call it as research protocol. Okay, you develop the specific questions according to your research question. Kecil-kecil. Yes.
Sorry, just wonder. Research protocol tu sama dengan interview protocol kah?
Ya, sama. Interview protocol sama. Research protocol, interview protocol sama. Okay.
And then the next question, do we develop our own interview protocol atau ada mana-mana guidelines to develop the protocol?
We develop
the university protocol ke?
We develop our own. According to the first research question, then probably you may develop another. You may develop 3 interview protocol. Boleh.
Okay.
Boleh dapat. That can help you, okay, to get more explanation from the respondent regarding your first RQ. Okay, so this question are also referred to as qualitative sub-questions, or in some qualitative literature as foreshadowed questions. Okay, it is important to note that this question may change as the study progress. Okay, it may transform. Okay, according to your respondent. Sometimes when you meet the first respondent, when you ask the respondent that particular question, the answer you receive is not as what you expect. So therefore, you need to change your interview protocol. Dia tak sama macam dalam kuanti. In kuanti, when you already started collecting your data, you cannot change anything. But in qualitative, it is transforming. It is progressing. You can add, you can delete, you can improve, and so on. Okay, so it is important to note that this question may change. Unlike their quantitative counterpart, whose research question remain constant throughout the research, qualitative research question are more flexible. Still, you boleh ubah RQ. Kita dah ada daripada awal tu sebagai panduan, but when we go to the field, it probably may change. Boleh berubah. Okay, dan dia biasanya berubah. Okay. They may use their early experiences in the research setting to modify or expand their research question. So itu dia punya basis. Dia boleh buat, because we are not yet in the field, kita tak tahu the actual situation. So when we are there, only then we know how difficult, how easy it is to interview our respondent. So baru kita tahu, only then we modify, okay, our research question or our interview protocol. Okay, qualitative research technique beyond observation bring the researcher in close contact with the participants in order to capture their perspective on the meaning of reality. So kalau we are interested to study their definition, what they view about leadership. So itu yang kita nak, dia perspektif. Okay. So additionally, qualitative researchers studies their participants in naturalistic setting while searching for the meaning and understanding of the human experience. So kita nak ni, dia punya pemahaman, dia punya perspektif, dia punya experience. Okay, and then how they give example based on whatever argument he or she provided to you. Okay, so saya rasa lagi ada lagi soalan tak? Saya stop kat situ lah hari ni. Tak masuk lagi hari ni.
So tadi tu dia punya keyword dia tadi from the informant punya point of view, emic kan doktor?
Yes, emic.
Okay. Thank you.
Lagi ada soalan tak? Qualitative. Any question? Ada so I thought.
Dr. Nomi, last question. Sorry.
Tak apa.
Ada satu mitos. People keep saying that qualitative research is very difficult to defend during Viva. Is it true or is it half true?
To me, both qual and quanti, they have their own risk. It has its own risk. But as long as you follow the right procedure for either qualitative or quanti, then you can do well during your Viva or during your examination. Because in previously qualitative not really been recognized in university or in any organization pun. But nowadays I can see that the qualitative study ni not just been accepted in the public in the university, but in most organization pun they are looking for qualitative expert. Meaning that they are aware about the uniqueness. Last time we are not interested in this uniqueness sebab tu susah nak diterima. Last time it is very difficult to defend on the quality of data. Quality. How do we ensure the quality of data? Because most of the researcher last time they are quantitative macam saya. So when we say how we ensure our data data are valid, so we look at our instrument validity, reliability. But in qualitative studies, saya rasa the most difficult part nowadays only on your design, to defend the design. In terms of data quality, you can prove in terms of the triangulation. For example, when you apply 3 methods, when you validate your data from 3 different sources, okay, from the interview, first one, from the report, available report, from your own field note, okay, from field note, any part, then from your observation, okay, ataupun audit trail, example. Okay, so this
members check pun okay kan?
Members check pun okay. So you already prove that you already validate your data from different sources. Triangulation. So itu sahaja sebenarnya. Paling susah sebenarnya you nak how you are going to defend your design. Sebab kualitatif ni design dia sangat susah nak dibezakan. Even when I ask for the qualitative expert pun dia tak boleh, orang kualitatif pun dia tak boleh nak bezakan the differences between the 5 ni until you conduct the study. Only then you can determine either the design is narrative ataupun grounded theory, dan next dan lain-lain. Kita buat dulu baru kita tahu. Walaupun early tu kita kata the study will be phenomenology. But after you conduct the study, so probably your study can change to descriptive. Boleh jadi. Dia progressing sama macam the RQ as well as the interview protocol. Dia boleh berubah, transforming. Okay, dia susah kat situ sikit.
Okay. Thank you, Dr. Nomi.
Okay, so any other question before we postpone our lecture to next week?
Doktor, nanti bila 8, can you please share the qualitative slide deck dekat PB?
Boleh. Saya cuba esok free sikit.
Esok Sabtu rehatlah dulu. Hari ni dah banyak.
Tak boleh dah, ya Allah, tak boleh dah. Saya nak mengejar masa ni. Letih saya dikejar masa. Okay, so thank you so much guys. So insyaAllah we'll see each other next week. So take care. Okay, see you again. Okay. Assalamualaikum.
Thank you, Doktor.
Thank you.
Thank you, Doktor.